What's going on, YouTube? So I posted a comment over the weekend on Future 4200 regarding my thoughts on the bubble hash machine we make, the solventless Mesclatore. And a lot of you have been reaching out and asking a whole bunch of questions and just giving me your opinions about what I said and what we're doing. And so I figured, hey, let's make a YouTube video to explain in depth our position and what we did and how we did it and what we think about what's going on with other systems and just my general opinion. And I'm going to take this at a very basic level. I think that it's too in-depth of a subject to make one video, so it'll get extremely boring. So anyways, if you're still interested, we will probably make subsequent videos so we can dive in depth into each individual position. Let's get to it. So, all right, thank you for listening. What is solventless? So for me, basics is just using water, ice to agitate trichomes off of biomass. Many plants have trichomes on them in general, so the application is broader than you may expect. The main function, what we're talking about here, is making, of course, bubble hash, and so it's a very simplistic way of removing cannabinoids from these plants. For the most part, it's just using cold water and agitation. And the way it functions is that the plant trichomes are made of lipids, fats, waxes, just plant waxes, plant fats. So these trichomes are actually on the outside of the plant. Removing them is extremely simple. Through agitation, there's an abscission point. These heads very easily fall off. So the point is to create a brittle trichome that easily falls off the plant without actually contaminating those trichomes by adding broken biomass. And so we do this by, again, using water. So you use the water to soak and you use the water to cool the trichomes to get you that brittleness and that perfect separation of the trichome from the biomass. That's basically it. Obviously, the term solventless is a misnomer because water is a solvent, but so you're using RO water, reverse osmosis. It's a very clean way of extracting, especially for the consumer that is concerned about using more dangerous chemicals. I don't have anything against using hydrocarbons or any kind of solvent, but some people may, and then there are some concerns. Some processors are less organized or more unscrupulous than others. It's also a way of taking a whole plant approach. If you want to talk about broad spectrum, you're getting a very broad spectrum through this process. Is it completely safe? I believe so. Yes, there may be some concern of pesticides, molds, and things like that. The process itself is not dangerous. When you're smoking the flower, or you're making any kind of product, you really need to watch out that the starting material is quality. It's not full of pesticides and all kinds of nasties. Kiki! The dog's going crazy. If you're familiar with our products, we make a filter trolley, a Buchner type vacuum assisted trolley with a diaphragm pump that is made of plastics. And in our opinion, the most successful bubble hash machine is the Bubble Magic. It's a plastic machine. A lot of the craft labs that we saw, the really good labs, they were using either a Brute bucket or a Bubble Magic. There's a reason why people are using plastics. So if you are one of those craftsmen that is making that 6-star full melt, really good high quality stuff, you understand the importance of plastics in the process, which is why the sifting is done with plastic screens. The problem is that metal tends to melt the trichomes. So if you don't watch out, and you're using a metal machine, the trichomes melt because the thermal transfer of the metal is very efficient. When you're scooping up trichomes from your screens, you'll even have your spoon inside of a cold water so that that metal remains cold, and all processing is done typically in a very cold room, 65, colder if you can, for that very reason, because the trichome will melt. So you can control the ambient temperature, but still you have to be careful that the machine that you're working with, the materials that you're working with, are not going to melt that hash. We see that we have the manufacturing expertise in plastics, and the plastics that we use are food grade plastics, and they are thermo-insulated materials. So instead of like a Brute or a Bubble Magic machine has very thin plastic, so it doesn't actually retain temperature very well. Our materials are extremely thick and they are great at retaining temperature. Unlike a metal machine, as soon as you drain a metal machine, it'll lose that coldness, it'll lose that temperature, so you really have to watch out. With our products, that plastic stays cold even after you drain it, so your hash doesn't stick to it. So it's really easy just to take some water and wash it down without having any fear or risk that hash is going to stick to it. So why did we decide to make a bubble hash machine? Because we have the manufacturing expertise in the material that we know is a winner. The second reason is that the industry is just going in that direction. I see more and more every day that craft cannabis, the connoisseur, the person that really knows, is going into solventless. There's a movement for bubble hash, for connoisseurs, for the more sophisticated consumer, or just the consumer that is looking for a more chemical-free, full broad spectrum approach to the plant. And what better way to do that than with the solventless product? It kind of hits two market segments that are very important. So you have the connoisseur, but then you also have the more conscious consumer that's concerned about harsh chemicals or whatnot. And you can have different price points and qualities with bubble hash, which I like. And you can make a ton of different SKUs on it. It's almost limitless what you can do with it. And there's different qualities, right? I mean, you can have very expensive per gram, $100 plus gram material, and you can have cheaper things to make gummies and things like that. But it's the manufacturing process that's important. The qualities and the price point's different. So why I also like it is because it allows the small craft cannabis operator to compete, because in order to make good bubble hash, fire in, fire out. That means you have to put in quality, and that requires work from the grower to be able to produce a high quality product. So solventless, bubble hash, and all these products give that small operator, that small craft cannabis, an edge, and it allows them to compete in a segment over these larger operations, because it's really hard to produce tons and tons of high quality material. So for a small manufacturer, I think it just makes complete business sense, and it allows those processors to stay in business and to compete with the people that are making distillate and isolate that is extremely capital intensive. Another reason why I like solventless is because to get into the business, you don't need a lot of cash. It's not capital intensive because the machines required simply are not as capital intensive as if you were making a distillate, isolate, or other products like that. Typically, it's simply taking fresh frozen flour, even dried flour, trim as well, putting it in cold water and agitating it. The water can have ice, but the function of the ice is not to agitate. The function of the ice is to keep the water cold. You agitate, the trichomes fall to the bottom of the tank, and then those get sieved and filtered out. So that's the process. In our system, the process is very similar. You fill your tank with biomass and water. You let it soak, you agitate, you filter, and then you repeat the process. Depending on the quality and the type of material that you're washing, you can wash it up to 5 times. We find 2 washes generally is enough. There's different power requirements based on the size of the batch, but generally it's that simple process. Fill, soak, agitate, filter, repeat. The process takes, depending on how many times you agitate, it could be somewhere from 2 hours to 4 hours. How is our process different? It really isn't. It's very similar to hand washing. The main difference is that it's an automated system. So if you are running a commercial operation, hand washing is labor intensive, so it can be expensive. But not just that, it's the repeatability is the issue, where if I'm feeling sick today and I'm the guy that's actually doing the agitation, I may not be fully concentrated, my body might not be there, and I won't be able to agitate that biomass at the same rate, at the same speed, at the same frequency that I would, was this a good day? And so what automation does is it creates that repeatability to allow you to consistently make the same product over and over and over without leaving money on the table. Because the goal of these machines is to remove as much of the trichomes from the flowers as possible without creating contaminants. If you add too much energy, if you agitate too much, the plant material starts to break up and you create contaminants. If you don't agitate enough, you leave money on the table by not fully extracting all of those trichomes from those plants. And we've seen this. We've done lab comparisons side by side, having vessels that are hand agitated with the same strain, the same material. You put them in the machine, and sometimes we had results that were night and day, where we had double the yield of the exact same material, the exact same quantities of fresh frozen. Sometimes it was double. So, and that can be attributed specifically to just the agitation. The guys that were hand agitating were not putting enough power in there to get the necessary yield to fulfill that potential. And all of this was without sacrificing the quality. One of the other ways that our process is different is that we do offer a continuous filtration option. One of the ways that our product is different is that we offer continuous filtration options, which means that instead of waiting for the trichomes to settle to the bottom of the tank, the trichomes are actually being removed from the slurry in real time. So as you're agitating, the trichomes are being pulled out of the system so they don't get banged up, they don't get deteriorated in any way. They just get pulled out in real time as they're coming off the plant. We have several systems. We have a vibrating sieve. This is our manufacturer that we use. It's a vibrating sieve. We also have a fluidized bed filter that's in development now. Is the machine difficult to operate? I don't think so. Generally, we recommend one user per trolley. So our machine it's modular, so you can have up to 5 trolleys for one mixer. But in general, I mean, the mechanics of filling and draining the machine are relatively simple. And then it has a computer-controlled PLC, which, here's a video of it. You know, you can make a recipe. It's highly customizable, but it's really simple to use. You push 1 or 2 buttons. Once you have your recipes, it repeats over and over and over again. You seem to use the recipes frequently. There's no need for complicated programming and extensive configurations. You push a button, the mixer starts to spin, and as soon as the mixing cycle is done, it stops. And then it does data logging for GMP purposes. We can even monitor the temperature throughout the whole agitation process. So there's a lot of stuff that it can do, but it really is simple. Yeah, you push the button, it starts, and then when it's finished, that's it. We designed the system to be really easy to clean, really easy to fill. So the trolleys fit through a normal doorway. They're not high at all. So a person can easily get to the bottom of that tank and clean it out. In general, we recommend 1 person per trolley. You can have multiple trolleys. This is what I'm talking about when I talk about the trolleys. So one mixer can power as many trolleys as you want. And 4 or 5 trolleys guarantees 100% utilization of the agitator. So you need one, but you can go up to 5. And we recommend that for every trolley you have an operator. So if you have 4 trolleys, because of the workload, it's probably best to have 3 or 4 people. If you have 1, obviously you just have to have 1. One person can operate just 1 trolley. And the batches can be anywhere from a pound to 35 kilos, more or less, depending on the type of material that you're washing. And the system is modular. It can do hundreds of pounds per day if you have the right setup. There's a couple ways to empty the vessels. So you can gravity drain. We do have a valve for gravity draining. So you can gravity drain it. but we also include a pump. The pump creates suction, and so the pump will make the draining a lot faster. And the pumps are hash pumps that will not damage the trichomes. You don't need to worry about that. We did all that math, we did all that work. We designed the pump specifically to avoid this kind of damage. And we offer not only diaphragm pumps, but also centrifugal pumps specifically made for hash. We get this a lot. This question comes up frequently where people typically think that the trolleys are made of steel, that the Mesclatore and the filters are made of steel. Actually, they're not. The Mesclatore is made of food-grade polypropylene plastic, and it's made out of very thick polypropylene plastic that is an insulator, and so it retains temperature really well. The plastics are actually made in Germany by a company called Simona, and we also work in Germany with Bayer, so we use their plastics, and everything's assembled in Italy. When people look at these machines, they think that it's made of steel because the plastic is so thick and it feels very rigid, very, very strong. It's easily confusable with steel, but it's very light, and these trolleys are very easy to move around your lab. Why plastics? I think I touched on this issue previously as to where plastics and bubble hash just work together. It's the perfect material to work with hash. So if you make hash, you know the benefits of using plastics. For us, it was not only that, but also the cost. Steel these days is extremely expensive. Not that plastic hasn't gone in price as well, but it's more cost effective, has more benefits, and also the manufacturing is fast. It's easier and faster to manufacture these materials than if this was a steel alternative. And so with steel, you're going to have more cost, more labor, and then all of the drawbacks associated with steel. I don't believe that this material has any of those drawbacks, and I can't identify why we would go to steel versus this construction material. That's a really good question. I think that the big concern that we have with plastics is single-use plastics, straws, bags, disposable cups, things of that nature for sure. But using plastics is not a safety concern from a health perspective. Like I mentioned previously, the plastics are made from reputable manufacturers, Bayer, Simona in Germany. Number two, they have a FDA conformity certificate. So these things are made to be in contact with food. The main question that I get is, because it's plastic, I think that the users have seen what these barrels and these brood vessels do, where they get all scratched up and things like that. They're different materials, right? Those are high density or low density polyethylene. We use polypropylene, and the material is very strong and it's very forgiving as well. It's easily repaired. If there's any kind of scuff or anything that you may be concerned of with a heat gun, those things conform back to their normal shape. So it's definitely a very strong material, and it's very forgiving. The other thing is that the type of product that we're processing has very low abrasion, and we do use bags inside of our systems. So just the potential for abrasion is very limited. It isn't the same as having a paddle in a brood vessel. You won't have that same amount of abrasion. If you notice, our tanks use big bags, and these bags perform several functions in the system. They influence fluid dynamics, they perform a filtration function, and they also make it really simple for cleanup, because you just pull out the whole bag and out comes all of your biomass. So it's a lot easier to use a system and then clean it out without actually having to get there with a scoop and scooping out all this biomass. But again, you can use these big bags, you can use no bags at all, or you can use the little cubes. Well, exactly what we've been talking about. Steel is very reliable, very strong, and it's going to last for a long time for sure. It's a great material, but that risk of having the hash stick to it and melt, degrading your product, is persistent. So we just try to stay away from steel as much as we can for that very same reason. I think that depends on the operator. We design our systems so they work with what you're doing. So if you're used to washing naked, that's what you like, power to you. We got you. If you're using cubes, in my opinion, is that you're looking for that ease of cleanup. And if that's what you want, then it's just makes more sense on a commercial scale to use a big bag that can just be hoisted up instead of using those cubes. The cubes affect the fluid dynamics, just the motion of the flour in there. And what happens is that users tend to pack those cubes a little bit too much, and it just throws everything off of whack. So I am not a fan. For me, obviously washing naked or washing with a bag are basically the same thing, just that washing with a bag makes cleanup a little bit easier. You compost it. If you're doing your job right, you are extracting the majority of the trichomes and cannabinoids from that biomass. So if you're doing right, you're not leaving enough money on the table to make it worthwhile. Typically, the price of biomass has been coming down, and I hear a lot of comments of people that are saying, well, maybe we should wash it with ethanol and try to recover what? There isn't much money there. Though it sounds like a good idea to reprocess this material to get some kind of money out of it, the reality is that you should do a side-by-side comparison of what it's going to cost you to extract that money left, and then see if it's actually valuable. I'll give you an example. So let's say that you had a farmer that brought you biomass that was 1% cannabinoids. Would you process that material? Would it be worthwhile for you? For some it may, but for most they would say, why would I bother? Because I can just take better quality material and use it with my limited resources. Most labs are at capacity, and there is a surplus of biomass. So for me, it doesn't make economical sense. It's just an argument to say, let's reprocess this. My personal opinion is just compost it. It's the best use of it. Yes. If the extraction is not perfect, yes, there's going to be cannabinoids left. And no extraction is perfect. There's always money on the table. The issue is, when you're doing bubble hash, is all of that water you're adding to the system. So you need to remove that water, because if you're using a solvent-based recovery, then that's going to denature your alcohol, and it just creates all kinds of problems. So again, yes, there are things left on the plant, but there shouldn't be that much. Bubble hash in general is typically very inefficient process, but the numbers are there. There's a financial case for it. Right, absolutely. You can use a centrifuge to remove the water from that biomass, and if you were to decide to reprocess it. But here's 2 points. How much is it going to cost you to reprocess? How much money are you going to get from that biomass? Yes, I've seen it too in other competitors, but the systems are like $250,000 when you have that whole system. I don't see it. You could go to a restaurant supply store and buy a salad spinner for a commercial salad spinner for $3,000. I don't think that the solution is buying a system that costs $250,000 when you can just get a salad spinner and do exactly the same thing as efficiently on the same commercial basis. So because of that, we didn't even bother to look for that solution, because that is something that already exists in the market, and it's not something that we can add value to. That's a great question. We use a top agitator for several reasons. Having a top agitator allows you to use multiple trolleys. And so the typical process requires a lot of settling, a lot of waiting around where you're actually not agitating. So in the meantime, the agitator isn't working when you're doing that settling. So we take advantage of that time by having an extra tank, putting it under the agitator and agitating. A lot of the process is just sitting and waiting. So If the system had the impeller, the agitator inside the tank, that system can't operate while it's settling, while you're sifting, while you're doing anything else. So it's loss of productivity. So by having trolleys that you can just switch, and when I say trolleys, I mean these things here, these things move in and out, and continue adding more trolleys. As you agitate, some are settling, some are soaking, some are draining, some are filtering, whatever. It continues the process. The other reason that we use a top agitator is that by having a top agitator, you can use bags. So you can line the tank with a bag. That makes cleanup so much easier, which you cannot do when you have the agitator inside the tank, because of course the agitator would chew up your bag. We don't have that problem.